Hello everyone, in this video I'll be talking about limits and continuity for TS EAMCET. Um, Only two questions were asked, actually three. The third question was more of part of definite integrals. Hence I have considered only two questions for now because the third problem I will be considering in definite integrals. So let us look at the first problem. F of r plus going to r be an increasing function such that f of x is greater than 0 for all x. If limit x tends to infinity, f of 9x divided by f of 3x is equal to 1, then limit of x tends to infinity, f of 6x by f of 3x is equals to what? So in this problem, since fx is an increasing function, we can write f of 3x is less than equal to f of 6x is less than equal to f of 9x, okay? We can easily mention that because fx is an increasing function for all x, okay? And when I divide by f of 3x, what will I get? F of 3x by f of 3x, which is 1, and f of 6x by f of 3x, which is what I want to know, and f of 9x by f of 3x. So the signs will stay the same because f of x is always positive for all x. It's given to us in the problem. If we say 3 is greater than 2, and if I divide both sides by minus 2, then I cannot say that minus 3 by 2 is greater than minus 2 by 2. This is minus 1.5 and this is minus 1. So minus 1.5 is less than 1, right? So it cannot stay the same sign, greater than sign, if I divide by negative number. Since I am dividing all of these by a number which is f of 3x, the sign is staying the same because this number is positive, which is given to us that f of x is greater than 0 for all x. So sign stays the same. So f of 3x by f of 3x is 1, and f of 9x by f of 3x is here, f of 6x by f of 3x is here. Now I am taking limit x tends to infinity on all these sides. So this will stay as constant, and this is the limit that we want to know, and this limit is given to us already, right? F of 9x by f of 3x for limit x tends to infinity equals to 1. So limit x tends to infinity for f of 6x by f of 3x is getting sandwiched between 1 and 1, right? So it's also called as sandwich theorem or two police theorem. So f of 6x by f of 3x, when you take limit x tends to infinity, is equals to 1, right? Now let us look at the second problem. So second problem states that let x square brackets x denote the greatest integer less than or equal to x, then f of x equals to 1 plus sine of greatest integer function of cos x divided by cos of greatest integer function of sine x. Now the problem is asking us whether the function is continuous on this interval or on this interval, whether it is continuous on this or is it continuous on this. How we can solve this problem is just define the function fx, and we will inspect the function and we will see whether it's continuous or discontinuous on all these intervals or not. In the problem we can see that it's asking on 0 to pi by 2, 0 to pi, pi to 3 pi by 2, pi to 2 pi. So I will define this function on 0 to 2 pi. Lower limit I will keep at 0 and upper limit I will keep at 2 pi, and I will define the function in this interval, and then I will see the discontinuity or continuity, okay? So how do I approach this? First I will draw the graph of this function sine x, and then subsequently we can see greatest integer function of sine x. How will that look like in 0 to 2 pi? So this wavy curve is function sine x, okay? It is 0 at 0, it is 1 at pi by 2, it is 0 at pi, it is minus 1 at 3 pi by 2, it is 0 at 2 pi again. So this black shows function fx is equal to sine x, and the red which I have written over here is y is equals to greatest integer function of sine x. So how do I draw this red curve? I've drawn it, but I will tell you how. So between 0 to pi by 2, all these values lie between 0 to 1, okay? Except at pi by 2 where it is equal to 1, so greatest integer function of 1 is equals to 1. So at pi by 2 my graph lies here at this point. And for all the values except pi by 2, the function lies between 0 to 1, as you can see here over here. So greatest integer of 0 will be what? 0. Greatest integer of 0.5 is equal to 0. Greatest integer of 0.999 is also equal to 0. So all these values which lie before pi by 2, all these have a greatest integer equal to 0, except when we reach pi by 2 it becomes 1. So greatest integer of 1 is equals to 1. So this is the function over here at pi by 2. Again, when we cross pi by 2 to pi, all these values lie between 1 and 0. So the greatest integer again will be 0. Now, as soon as I cross pi, the value lies between 0 and minus 1. So greatest integer function of minus 0.01 is equal to minus 1. We know that, right? We know this. So for this point, just after crossing pi, the greatest integer function is minus 1. So it lies over here. For this point as well is minus 1. For this point as well, minus 1. At this point, the value is minus 1. So it will stay at minus 1. At this point as well, all these points between pi to 2 pi have a greatest integer function equal to minus 1. Except when I reach 2 pi, it's 0. So greatest integer of 0 is 0. Greatest integer function of 0 is 0. So this will be my graph. Okay. You can define it. I have done it. Greatest integer function of sin x equals to 0 if x lies between 0 to pi by 2. It is 1 if x equals to pi by 2. It is 0 again when it crosses pi by 2 and reaches pi. And it becomes minus 1 when x goes from pi to 2 pi. And it becomes 0 when x equals to 2 pi. So this is how you define the greatest integer function of sin x. Now I have done it for sin x. Can you think of how we can do it for cos x? Again, it's completely similar to what I have done for sin x. Just draw the graph for cosine of x. Okay, we know that cos of 0 equals to 1, cos pi by 2 is equals to 0, cos pi is minus 1, cos 3 pi by 2 is 0, cos 2 pi is again 1. So like I had done for sin x, I have drawn the greatest integer function of cos x in red over here. So at x equals to 0, value is 1, so greatest integer function is 1. But for all the values between 0 to pi by 2, the value of cos x is between 1 and 0, so their greatest integer function is 0. Now as soon as I cross pi by 2, the value is like very slightly negative number, maybe 0.01, minus 0.01, minus 0.02. All of them will have a greatest integer function of minus 1, and this will continue till you reach 3 pi by 2. When you reach 3 pi by 2, the value is 0. So greatest integer function of 0 is 0. Now as soon as you cross 3 pi by 2 on to the right, the value is very slightly positive, maybe 0.01, 0.02, 0.03, or 0.5, 0.99. All these values have a greatest integer function equal to 0. Except when you reach 2 pi, it is again 1. Cos of 2 pi is 1. So the greatest integer function of 1 is 1. So this is the graph of greatest integer function of cos x drawn in red. You can express it this way. Greatest integer function of cos x equals to 1 if x equals to 0 is 0 if x lies between 0 to pi by 2. Pi by 2 is included. Minus 1 when the function is between pi by 2 to 3 pi by 2. Over here, minus 1, both the values are excluded. And it is equal to 0 when x lies between 3 pi by 2 to 2 pi. 3 pi by 2 is included as I have shown here. And 1 if x equals to 2 pi. So I have defined greatest integer function of sin x between 0 to 2 pi and I have defined greatest integer function of cos x between 0 to 2 pi. Okay, so now we can define cos x as well. We will divide it in 4 intervals, 0 to pi by 2 and pi by 2 to pi, and pi to 3 pi by 2 and 3 pi by 2 to 2 pi. And we are also going to consider x equals to pi by 2 and 2 pi as separate points, because as you can see, at pi by 2 the function becomes 1 plus sine 0 by cos 1, and before pi by 2 it was 1 plus sine 0 by cos 0. How do you get cos 0? In the function you have cos of greatest integer of sine x. What is the value of greatest integer of sine x when x equals to pi by 2? It's 1, right? So it's 1. So it's over here, when x equals to pi by 2 it becomes cos 1. But when x is between 0 to pi by 2, you can see 0 to pi by 2 greatest integer of sine x is 0. So this will become cos 0. What is cos 0? Cos 0 is 1. So over here you see cos 0, and over here you see cos 1. Sine 0 stays the same, and the value is also 0. So if x belongs to 0 to pi by 2, the value of function is 1. But as soon as x equals to pi by 2, it becomes 1 upon cos 1. And cos 1 is not 1, okay? So these two values are different. Hence, you can see the function is not continuous between 0 to pi, because there is a break at x equal to pi by 2, right? So continuous on 0 to pi? No. But continuous on 0 to pi by 2? Yes. So I know that the option A is correct because I have already defined it in 0 to pi by 2, which is 1. So I already know the correct answer. But let us also examine pi to 2 pi as well, right? So let us continue further. I put the values when you go from pi by 2 to pi. This is sine of greatest integer function of cos x. Let us look at the function greatest integer of cos x between pi by 2 to pi. Pi by 2 to pi is minus 1. So sine of minus 1. And cos, let us look at pi by 2 to pi for greatest integer of sine x. Again 0. Pi by 2 to pi is 0. So you will get cos 0 in the denominator, and 1 plus sine of minus 1. Now sine of minus x equals to minus sine x, so it will become 1 minus sine 1. And cos 0 is 1, so this will stay as 1 minus sine 1 when x belongs to pi by 2 to pi. Okay. Now when we reach pi to 3 pi by 2, when we reach pi to 3 pi by 2, pi to 3 pi by 2, okay, the greatest integer of sine x is what? Minus 1. Minus 1. So you have minus 1 in the denominator, because in the denominator of the function it's cos of greatest integer of sine x. So greatest integer of sine x is minus 1 between pi to 3 pi by 2. So you get cos of minus 1, which is cos 1, because cos is an even function. Cos of minus x equals to cos x. So you get cos x over here. So as you can see, the definition has changed when you go from pi by 2 to pi to 3 pi by 2. Similarly, I have done it for 3 pi by 2 to 2 pi and x equals to 2 pi. This will be the definition of function fx. So as you can see, fx is continuous on 0 to pi by 2. Option A is correct, rest are incorrect. What is the rest of the options? Continuous on pi to 2 pi. Let us look at D first. Continuous on pi to 2 pi. Pi to 2 pi. No, because the value has changed. Because the value has changed, all of a sudden it's not continuous. So D is also incorrect. Discontinuous on pi to 3 pi by 2. Discontinuous on pi to 3 pi by 2? No, because the value stays the same. So this is also wrong. Hence option A is correct. Right? So we are done with the two questions on limits and continuity that were asked in this exam. I will continue with the rest of the calculus in the next videos, which is integral calculus and differential calculus. which includes area under the curve, indefinite integrals, definite integrals, differential equations, etc. etc. So, thank you everyone.